question number 1 is asking us which equation has the same solution as the quadratic shown. If I look at my 4 choices, all of them are in the same form, which comes from the completing the square process. So I'm going to take my quadratic and complete the square until I get it into the format of my choices. So I have x squared minus 6x. I brought my constant over to the right-hand side of my equation, and now I'm going to add that square to both sides. Remember, when we complete the square, we add those blank squares so that we can then take that b value, which in this case is negative 6, divide it by 2, and square it. So I end up with negative 3 squared, which gives me a positive 9, which I'm going to add to both sides of my equation. Now I'm going to factor this trinomial, which has now turned into a perfect square trinomial. And if I don't want to think about the factoring, I can always remember that the number I get before I square is the number that goes into my binomial factors. So we'll add 12 and 9, we'll get 21. Rewrite x minus 3 times x minus 3 as x minus 3 squared equal to 21, which gives me choice 4. You also could have typed your original quadratic into your y equals, typed in your 4 choices one by one, and see which of the graphs matched the original. Another way you could do it in the calculator. Question 2 says, what are the zeros of this function? One way to approach this would be to type all of your choices in for x, store them, and see which ones make your equation equal to 0. Or I can actually algebraically solve this. If I'm looking for the zeros, that means my y value is 0, and I need to solve for x. I'm able to solve this using the square root method. I'm going to take the square root of both sides, not forgetting my plus or minus. So the plus or minus square root of 25 will give me the plus or minus of 5. X minus 2 squared, square rooted, just gives me x minus 2. And then if I add 2 to both sides, I end up with 2 plus or minus 5 equal to x. I'm going to actually take a step and add 2 and 5, and then subtract 2 and 5 to get 2 answers of 7 and negative 3. For question 3, we're being told that this student needs to solve the problem below using the quadratic formula. Which of the following choices shows the formula being used correctly? So this formula was given to you on the test, so I'll just rewrite it here for us. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, that's on your Regents reference sheet. That will be provided for you. I need to now look at my quadratic, and I need to make sure it's in standard form, which right now it's not. So I'm going to rewrite it as x squared plus 8x plus 15 is equal to 0. Now I can identify that my a value is 1, that's my leading coefficient. My b value is 8. My c value is 15. And now I'd like to calculate my discriminant, which again comes from that value underneath your square root. So this b squared minus 4ac is my discriminant. And since my b is 8, and my a is 1, and my c is 15, if I calculate that in one step in my calculator, I should end up with, I would end up with 4. Now, I went a little beyond where we need to go, because now I'm looking at my choices, realizing that I didn't have to actually calculate this 4, because all of my choices just have the correct plug-in. So now I'm going to just plug everything in. So x equals negative b plus or minus the square root. So since we didn't actually have to calculate this, let me just plug in all over 2 times a, which is 1. So I'm looking for this choice, and this is correct on choice 4. Question 4 is asking us to take this quadratic that was being solved by the student Sam. They were asked to complete the square. Which equation could have been my original equation to the one that is shown here? Okay, so when I'm looking at question 4, the one way you could approach it, since this is partially solved by completing the square, you could take each choice and start trying to get them into that form using the completing the square method. But because this will take a long time, I would like to show you a shortcut with this question. So I'm going to go to my calculator, and I'm going to type in the original quadratic. But in order to type this in, I do have to get it equal to 0. So I'm going to subtract over the 13 over 4, set it equal to 0, and type this into my y equals. So it looks something like that. Now I'm going to take each choice and type them in and see which one matches the quadratic that I have. So here is choice 1. Choice 1 is in red and my original is in blue, and I can see they do not match. Here is my second choice, and if I hit graph here, I'm going to take a look to see if they are mapped on top of each other, and they are not. So again, I can get rid of choice 2. Here's choice 3. Let's hit graph and see if these two graphs match up. And again, they do not. So now I know that I've narrowed it down to only choice 4, but let's just take a look at it. And finally, the answer that we know is going to be correct. Here's my original graph, and you can see that my choice 4 equation maps right on top of it. So this quadratic is equal to this quadratic, choice 4. Number 5, when factored completely, what is this expression equivalent to? So again, when I factor, I always look for a GCF first, and in this expression, I do have a GCF of 2, which is going to leave me with n. Sorry about that. N to the 4th minus 16. Now it looks like I have the difference of 2 squares, so I'm going to factor that one step further. N squared plus 4, n squared minus 4, since the square root of n to the 4th would be n to the 2nd, and the square root of 16 gives me 4. Now, my 2 is factored completely, the n squared plus 4 is factored completely, but my last factor here, n squared minus 4, is the difference of 2 squares again. Square root of 4 gives me 2, the square root of n squared gives me n. So I'm going to go one step further, bring down my factors that are not changing, and then I end up with n plus 2 and n minus 2. This required all 3 factoring steps to get me to choice 3. Question 6 is asking us which equation is represented by the graph below. So I have a linear function, so I'm reminding myself that y equals mx plus b is the standard form of a linear function. Here is my y-intercept, and it's down at -5. And then I want to look to see my slope. I can see it's going in a negative direction. And it's appearing to go down 2 over 1, down 2 over 1, or up 2, left 1, up 2, left 1. So my slope is -2. Bring this together to get an equation of -2x minus 5. I look at my 4 choices, and I don't exactly see any of them in y equals. So you would need to take a step to solve them all for y. And once all 4 choices are solved for y, we can see that choice 4 has my equation, y equals -2x minus 5.
On number 7, they say Emily is given a rectangular piece of paper, and the length of her paper is represented by 3x plus 12, and the width is represented by x minus 7. So as soon as they're telling me I'm talking about a piece of paper, I'm going to draw a rectangle, and I'm going to label these 2 sides. So I have one side is 3x plus 2, and the other side is x minus 7. They said they want to know the total area. Well, I know that area is my length times my width. To find my area, I actually need to take these 2 and multiply them. So I have 3x plus 2 times this x minus 7. In order to do this, I can either do the box method or I can double distribute. So if I do 3x times x, I get 3x squared. If I do 3x times a -7, I'm going to get -21x. 2 times x, I'm going to get plus 2x. And 2 times a -7 is -14. Now I do need to combine my like terms. So I'm going to have that my area is 3x squared minus 19x minus that 14. If I look, this does match up with choice. And number 8, they ask what is 3 radical 250 expressed in simplest radical form. Well, first I'm going to start with rewriting this. And I do want to use my calculator to help me with this. Okay, so in my calculator, I'm going to, in my y1, I'm going to put x squared, and what that's going to give me is that's going to give me all of my perfect squares. And my y2, I'm going to put 250 divided by x, and what that's going to do is give me all of my factors of 250. And I'm going to actually look at my table, and I want to find two numbers that multiply and that are going to give me one of these perfect squares. I'm looking for one of these that are in one of my other columns. So if I look, I actually have 25 times 10 is actually my perfect square. So I have that 25 as a perfect square. When I break this up, I'm going to have 3. The square root of 25 is my perfect square, and 25 times 10 is how I get that 250. If I actually take the square root of 25, that is 5. And I still have this 10 underneath my radical because that cannot be simplified any further. And if I just multiply my 3 times my 5, I do get 15 radical 10. And that is choice number 3. Erase this so we can read the next question. So number 9, the cost of a plane ticket is usually comprised of a base fee that includes a certain number of bags and an overcharge to bring more luggage on the flight. An airplane company charges $150 per ticket. This is some important information. And an overcharge of $20 per bag that exceeds the initial 2 bags allowance. If C is the cost and B represents the total number of bags, which equation could represent the cost of the ticket when more than 2 bags are brought on the flight? So this equation, if we look at all of these, I know that it's an initial fee of $150. So right away, I know that I can cross these off because the 1 and 2 both have that initial fee of $150, and this $20 is going with something that it is cheap. To really determine between the two of these, you could absolutely take a value and plug it in and see what would work, which one actually gives you the right thing. So if I have 3 bags, so let's say bags is 3, I have 3 bags, it would be $150 plus another $20 for that additional bag. So it should be $170. And what I would do is I would plug in that into these equations and see which one works. So I did go ahead and plug in 3 bags for both equations for number 1 and 2. And when I plugged in for number 1, I got a value of 130. Which I know that this value needs to be 170. It doesn't make sense that if I bring more bags, it's actually going to be less money. So that is why choice number 2 is correct. If I do plug in those 3 bags, I do get that $170 that it should be if I bring 1 additional bag. So that is why it is choice 2. We want to take that number of bags, which is B, and we want to subtract those 2 bags because I don't have to pay that for those 2 bags. So for number 10, we do have to solve this inequality that they gave us. In order to do this, I want to get all my terms that have an x, and I just rewrote this over here. I want to get all my terms that have an x over to one side. So in order to move this 3/4 x to the other side, I'm going to subtract 3/4 x from both sides. When I subtract that, you can do that right in your calculator, I would get 5/4 x. I still have this minus 1, and it's still less than 9. Again, I want to get my x term by itself, so if I add 1 on both sides, I would get that 5/4x is less than 9. Now, I do need to continue to get x by itself, so in order to do that, undo this multiplying by 5/4, so I'm going to multiply by its reciprocal. So multiply by 4/5 on both sides. And if I do that, I will get that x is less than 8. And that is choice number 4. Number 11 says subtract this expression from this other one. They say express the result in simplest radical form. As soon as I see this word from, that means that I need to actually switch the order that I'm going to be doing this subtraction. So I do want to take 2x squared minus 3x minus 9, and I want to subtract the 7x squared minus 3x plus 5. So I want to subtract that from the second one that they gave me. Now, the first thing that I do need to do is I have this negative here. I need to make sure that I distribute this negative to each term. So my first three terms do not change, but then I have a negative 7x squared plus 3x minus 5. My final step is I need to combine my like terms. So I look, I have 2x squared and a negative 7x squared, so that gives me a negative 5x squared. I have a negative 3x and a positive 3x. Those terms actually cancel each other out. So I don't have a term there. And then I finally have a negative 9x and a negative 5x, so I end up with negative 40. So my final answer is negative 5x squared minus 14. On number 12, they say determine and state which table represents a function, and then explain your answer. So if we recall the definition of a function, it's for every x value we only have one unique y value. Or for every input, there is only one output. So if we look at choice A, we see we have 2, 3, 4, 5, 2, 7, 4, 9. So in this table, we do see that we have an input of 4 and we get a 5. We have an input of 4 and we get a 9. So choice A is not a function. If I look at B, again, I have an input of 0. That gives me an output of 0. An input of 0, that gives me an output of negative 1. That is not a function either. If I look at C, each input does look, or each x value does look like it has its own unique y value. This y value of 2 does repeat, but again, if we think of that graphically, I have 1. If I have the value 3, 2 would be somewhere there, and I have the 0.72, that's somewhere there, and I think graphically we said it needs to make sure it passes the vertical line test, so that does still pass the vertical line test, even though those y values do repeat. It is still a function. So C is our function, and again, if I look here, I have those x values repeating with y values. And the reason why, so I'm going to say table C, and this is a function because for every x value in the table, there is a unique y value. Or you could also say that the x values do not repeat. And number 13, determine the roots of the equation algebraically. So we recall roots are the same things as zeros, same things as x-intercepts. So in order to solve this, we either want to factor, or we want to do completing the square, or quadratic formula. So if I look here, if I try to factor this, I have a trinomial. So first I look for a GCF. I don't have a DCF. I then look if I can do dots. I cannot do dots because I don't have 2 terms. I have 3 terms. So I do look for tram. And if I try to do tram, I want to add to a positive 4 and multiply to a negative 16. And there are not 2 values that add to a positive 4 multiplied to a negative 16. So I actually cannot do tram here either. I cannot do any type of our factoring methods to solve this. I am going to need to do either completing the square or the quadratic formula. Since we already did a quadratic formula on this exam, I will do completing the square. So I have x squared plus 4x. And I do want to move this 16 over to the other side, so I'm going to add 16 on both sides. Once I do that, I do add that box to each side. And what goes in the box is I take my b value, which is 4, I divide it by 2, and I square it. So that gives me 2 squared, which gives me 4. So 4 is what I'm actually adding into both of those boxes. I now, on my left-hand side, I want to factor this trinomial. Again, I can look at what was inside of here. That is what my factors are going to be. So x plus 2 and x plus 2, or I could have done tram, so 2 things that add to 4, and also multiply to 4 would be 2 times 2. And that's going to equal 20. Since I have the 2 binomials multiplied by itself, I can rewrite it as x plus 2 squared, and that equals 20. Now that I have this binomial squared, I can absolutely take the square root of on the other side. And don't forget our plus or minus there when I myself are drawing in that square root. These cancel out. I'm left with x plus 2 equals a plus or minus radical 20. Now, I do want to simplify that radical 20. So, x plus 2 equals, I keep my plus or minus. I'm thinking of two things that are going to multiply to 20, and I need one of them to be a perfect square. So that's 4 times 5, and 4 is my perfect square. So this is going to simplify to the square root of 4 is 2 radical 5, and I cannot simplify radical 5 anymore. And over here I still have my x plus 2. In order to solve for my roots, or my zeros, or my x-intercepts, I need to get x by itself. So I do need to subtract this 2 on both sides. I would get that x equals negative 2 plus or minus 2 radical 5. And at this point, I cannot actually subtract or add these values because this 2 is with the radical 5, so I cannot combine those 2's. I do need to just leave it just like that.
Okay, for question 14, we're looking at a question that's involving two girls, Sarah and Alice, going to a food court. They're purchasing lunch for their group of friends. So it tells us that Sarah is ordering 2 burgers and 3 orders of fries and spends a total of $19.75. Alice orders 5 burgers and 2 orders of fries and spends a total of $37. So we're dealing right now with burgers, amount of burgers, and amount of orders of fries. So we need some let statements here. So I'm going to let B equal the cost of a burger. Since we know how many they're getting, we just don't know how much they cost. And we're going to let F equal the cost of the order of fries. So we're being asked to find the cost for a burger and order of fries. That also helps you, that last line can help you write your let statements. You know what to let these variables equal. Now it tells us only an algebraic solution will be accepted, so now I need to start to form some equations here to solve. So for Sarah, she's ordering 2 burgers and 3 orders of fries, and she's spending $19.75. There's my first equation. Alice orders 5 burgers and 2 orders of fries, and she's spending a total of $37. So I have a system of equations here. In order to solve for 2 variables, I need 2 equations, and I'm going to solve this using elimination. So I'm going to take my first equation and multiply it by negative 2, and I'm going to take my second equation and I'm going to multiply it by 3. And I'm going to rewrite them right under here. So if I start with my first equation, I'm going to distribute in that negative 2. I end up with a negative 4b minus 6f is equal to negative 3950. Please type in negative 2 times 1975. Don't forget to distribute the negative everywhere. And then I'm going to distribute in this 3. 3 times 5, that's going to give me 15b plus 6f is equal to $111. Now, the reason I multiplied by a positive and a negative, 2 and 3, was so that I could isolate this f and cancel it out. Now I have a negative 6f and a positive 6f. I'm going to cancel them. I'm going to add straight down. Negative 4b plus 15b is going to give me an 11b equal to negative 3950 plus 111 is going to give me 7150. I'm going to save myself a little room here. I'm going to come over here. 11b is equal to that 7150. I'm going to divide by 11, and I get a b value of 6.50. So now I know that a burger costs $6.50. If I want to figure out how much an order of fries costs, I need to plug this into one of my equations. I'm going to plug it in to my first equation. So 2b, or 2 times 650, plus 3f is equal to 1975. Okay, solve for f now, so I'm going to end up with 13 plus 3f equals 1975. Subtract the 13. I get 3f is equal to 675. Divide by 3. F equals 2.25. So an order of fries costs $2.25, and a burger costs $6.50. Okay, for question 15, the last question on this test, It's talking about a landscaper creating a rectangular flower bed. I'm going to draw myself a rectangle where the width is half of the length. So if I let x equal the length, maybe I'll label my length x. If the width is half of the length, that means my width is 1/2 x. So you don't need the let statement and the diagram, but you do need one or the other. They then go on to tell me that the area of the flower bed, or this rectangular shape that I'm drawing here, is 34 square feet. Write and solve an equation to determine the width of the flower bed. So area is length times width. So 34 is equal to my length times my width. Ends up with 34 is equal to 1/2 x squared. One way to get rid of that fraction, you could multiply both sides of your equation by 2 to isolate x squared, and we end up with 68 is equal to x squared. I can solve this quadratic using just the square root method since I've already isolated x squared. So plus or minus the square root of 68 is equal to x, since x squared is square rooted. Don't forget your plus or minus in front of that square root of 68. And now I need to determine the biggest perfect square that goes into 68. Okay, so I go to my table. I first go to my y equals, type in 68 divided by x so I can see all the factors of 68, go to my table to actually see them, and I'm looking for the biggest perfect square that goes into 68. And I'm looking here, and I see 4 times 17. 4 is the biggest perfect square that goes into that number. So I'm going to break this down a little bit further. 4 times 17 is equal to 68. 4 is my perfect square. That's going to come in front of the radical now as a 2. So now I need to actually go back and read the rest of this information so I know that I answered the question correctly. So I've solved for x completely. Plus or minus 2 rad 17 is x. Let's see what they're asking me to solve it for. I'm being asked to solve for the width of the flower bed to the nearest 1/10 of a foot. Okay, so the width is actually equal to 1/2 x, and they're asking me to round. So the nice thing about that is that I can actually now go and type this into my calculator. So for those of us that didn't simplify the radical, it's actually okay. So even though we ended up with this, if we had left it like this, we would have still been able to get the answer. Now, x is not what I need. I actually need 1/2 x. So my width is 1/2 of this square root of 68. Now, at this point, I dropped my plus or minus because we're talking about a dimension here. And if I have a negative length or width, that doesn't really work in the context of this question. We can't have a negative amount of a foot. So I'm going to reject the negative, and now I'm just going to focus on finding 1/2 of the square root of 68. I'm going to go back to my calculator. I'm going to go to my home screen. I'm going to type in 1/2 or 0.5 times that square root of 68. And we're being asked to round to the nearest 10th, so the width is 4.1 feet. So we definitely needed to review simplifying radicals because that is something that could come up, but because we were being asked to round to the nearest 10th, we didn't actually have to leave our answer in simplest radical form. We were able to type it in and round to the nearest 10th.